What's up? This is Madan sir here, and I have come up with another topic from alcohol, phenol, and ether. And this is going to be a short one and also very important one. This is called acetylation, right? What acetylation means here? I mentioned already a line here. What acetylation is? Introduction of acetyl group. What acetyl group is? Probably you remember. In case you do not, CH3CO. This is the group called acetyl group. So introduction of acetyl group in an alcohol and phenol, this is called acetylation. So this is what, I'm talking right now. Let me introduce to you a bit about, then I will explain the equation. Acetylation is a simple, chemical equation, which you're really going to get it very easy. Acetyl group, when added to alcohol and phenol can be, very much useful. And one of such example is, something really, really important. We are almost familiar in our day-to-day life. If you remember aspirin, we popularly also call it Aspirin, aspirin or whatever, we probably remember. So aspirin is one such compound where acetyl group is introduced in a compound called salicylic acid. So aspirin is nothing but an acetylated salicylic acid. What salicylic acid is, I'm coming to that. I was just wanted to introduce to you what this topic is. So let me repeat back. Introduction of this group, CH3CO, also called acetyl group, to alcohol and phenol is called acetylation. And for example, I'm taking, the example we have this particular reaction. This is benzene. If you place OH here, this is called phenol. But if you place carboxylic group here, this becomes 2-hydroxybenzoic acid. 2-hydroxybenzoic acid. Benzoic acid. But this is also called salicylic acid. I hope I am writing the spelling correctly. Salicylic acid. Right? So this 2-hydroxybenzoic acid is also called salicylic acid. And what you have to do, you have to add, acetic anhydride. So what acetic anhydride is? This is going to be easy here. I've done, similar reaction in the past as well. So this is what, acetic anhydride is. Acetic anhydride. Now, if you take a look, you have two acetyl group here. You have two acetyl group. These are acetyl. Acetyl. This is also an acetyl. Right? So in acetic anhydride, there are two acetyl group, right? So this was just to make you understand what acetyl group is. Now I have to wipe this off because I want to explain you something else, right? So I've already, represented here. So this is your acetic anhydride is where there are two acetyl group. Now what happened? Benzoic acids donate a proton. Therefore, this oxygen becomes a negatively charged particle. Similarly, if you break the bond right here or right there, this will, break in such a way that this becomes a positively charged, while this will be entirely, I hope it's not messing up. This will be entirely a negative charge, right? So just put this one, hydrogen with this negative one, and that's going to be like CH3, C double bond O, and then you have OH. So this comes out to be ethanoic acid. Ethanoic acid. This is a byproduct here. What another main product is going to be, this oxygen will attach to the carbon. So this is your carboxylic group, and there you had oxygen. Now the oxygen will come up with carbon. Carbon, again a double bond, oxygen, this one, this one, and CH3. This is what the thing. So this is called acetyl salicylic acid. Salicylic acid. And we also call it aspirin. We also call it aspirin, the painkiller. The painkiller. It sounds funny that I'm naming something like this, but I just want to make sure you get some interest in it. So this is what the reaction is. This is what acetylation is, and this is how acetylation of salicylic acid can result formation of aspirin, right? So let me repeat back everything about, so that you understand really well. Acetylation refers to introduction of acetyl group in alcohol and phenol. What acetyl group is? CH3CO. One such example is aspirin. Aspirin is really important chemical because we remember it as a painkiller, one of the most common. And aspirin is nothing but acetylated salicylic acid. How it is prepared? It is prepared from salicylic acid, which scientifically is called 2-hydroxybenzoic acid. So this is what hydroxybenzoic acid is. When you react 2-hydroxybenzoic acid with acidic anhydride, you can make the bond, any one, undergo cleavage, but it should be between carbon and oxygen. Remember, carbon and oxygen. So either this bond can break or this bond can break. So if this bond breaks, electron will shift towards oxygen. So this becomes a negative charge, and the carbon and this whole part becomes a positive charge. So what you need to do, since this acid is a stronger acid, let me compare here. This is a stronger proton donor. I'm just writing so that you can stronger proton donor, right? So this is a stronger proton donor, so that's why the bond between O and H breaks. So this is acting as a nucleophile, and this part is acting as a electrophile. So this nucleophile and this electrophile comes together to form this particular compound. What you have to do, just add this positive to the negative and positive to the negative here. So one of the byproduct is ethanoic acid. Other main product is aspirin, the painkiller, also called acetyl salicylic acid. So this was the very small topic I wanted to do today because I'm not feeling that well. I would say, I hope you have understand that, one very important line I want to talk to you about, that most of the time alcohol, when react with other reagent, it undergo cleavage of bond between carbon and oxygen. Alcohol mostly act as a electrophile. Phenol act as a electrophile only when it react with zinc. But that's something I will discuss in the coming section. I wanted to let you know what this is. So that's it. I have to finish it right here. I'll say thanks for watching. Good night.